A large conviction among most investigators is that the speculation of how things came to be stays the major clarification for the early times of the universe. This hypothesis joins the development of stars, planets, and henceforward life on those planets, including ourselves. Notwithstanding its odd name, the huge explosion offers an illuminating assessment concerning what could have occurred. At first, the universe was dense in a short space, more dense than a pinhead with particles thickly packed. From this moment, a giant effect of matter and energy occurred, known as the enormous detonation. This event, happening billions of years ago, set up the fanning out of cosmic history. In any case, in scientific understanding, it has triggered developing anomalies with the assumptions of this hypothesis. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever, experts estimated that its insights would confirm the hypothesis of the universe's origin. Unfortunately, after only 1 year in space, the telescope stunned experts with its ability to peer so deeply into the universe's past. The James Webb Telescope's dazzling capabilities have revealed countless galaxies, going as far back to a period so old that it challenges our understanding of the universe's beginnings. This discovery has sparked a serious examination concerning what existed before the enormous detonation. One crucial moment in this mission happened when cosmologist Rohan Natu, working with data from the telescope, unexpectedly discovered a system from just a short time after the enormous bang, making it the most distant universe ever seen. Natu's discovery sent shockwaves through established experts, highlighting the amazing abilities of the James Webb Telescope. Its gigantic objective to change our perspective on the universe has only just begun, promising to reveal astonishing insights into the earliest times of the universe's existence. This period, scarcely focused on before, holds the key to understanding the evolution of the first stars and galaxies. The telescope's discoveries have clashed with central hypotheses, revealing systems with attributes surpassing past assumptions. This unprecedented surge of early galaxies has ignited a storm of scientific inquiry, challenging experts to reconcile these revelations with existing theories. As scientists uncover these findings, they face key questions about the very nature of the universe and the forces that shaped its development. Beyond the James Webb Telescope's advancements, which are clear, it is positioned 1.5 million kilometers away from Earth, shielded from cosmic interference and cooled to near absolute zero by its tennis court-sized sunshield. The telescope incorporates a large segmented mirror and incredibly sensitive instruments designed to uncover details of the early universe previously hidden. This period, known as the Cosmic Dawn, occurred around 200 to 300 million years after the enormous detonation, marking the moment when the first stars and galaxies began to form. The process by which this unfolded remains a subject of intense examination, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the cosmic dawn presents a unique opportunity for cosmologists to test how they might interpret these complex components. By studying these ancient systems, researchers can either confirm the validity of their current models or uncover gaps in understanding that could lead to major new discoveries. From the outset, the telescope was expected to observe only a few faint and small galaxies in its pilot studies. However, reality has far surpassed these assumptions. The telescope's initial photos of the distant universe revealed an abundance of galaxies with ages, sizes, and brightness levels that defied all expectations. This astonishing surge of early galaxies has sparked a race among space scientists to establish new benchmarks for the earliest known cosmic systems, with new revelations emerging constantly, leaving conventional experts in awe. Following the James Webb Telescope's exposures, top specialists and observers have rushed to study the presence of these surprisingly advanced early galaxies. Some speculated that errors in the telescope's interpretation of massive observations could be responsible for these surprising discoveries. That said, the consensus remains that these revelations represent a paradigm shift in how we understand the early universe and offer exciting glimpses into the potential for cosmic evolution. The new discoveries from the James Webb Space Telescope about galaxies have raised significant questions about the nature of the universe and tested the assumptions of standard cosmological models. While some experts are examining whether these insights can be accommodated with existing theories, Others propose that they might be the first signs that the universe is far more complex and mysterious than previously imagined. The key question at play is our fundamental understanding of how the universe we know emerged out of primordial chaos. The early discoveries of the JWST could reshape our foundational ideas of cosmic history, revealing insights not just on distant galaxies and ancient structures but also on the very nature of our own Milky Way. As Mark McCaffrian, Senior Advisor for Science and Exploration at the European Space Agency, puts it, "You build these machines not to confirm theory but to break it. You just have no idea how it will break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At that time, Garth Weir, then head of STSCI, was tasked with envisioning what could come after Hubble. Despite initial doubts, Weir and a small team began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared range, allowing it to peer much deeper into the universe. This capability is crucial for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its massive, cold, star-like mirror, the JWST became the premier instrument for uncovering the secrets of the cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field observation revealed countless galaxies in what was once thought to be an empty patch of sky. This discovery demonstrated the richness of the early universe and underscored the need for a telescope capable of probing much further into galactic history. Following 20 exhausting years of development and a cost of around $10 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most critical year of scientific observations. Early initiatives like the Early Release Science Program and the General Observing Program were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. JWST observations have tested existing models of the early universe, revealing galaxies that challenge traditional cosmological assumptions. These stunning discoveries highlight the importance of pushing the boundaries of scientific inquiry and showcase the extraordinary capabilities of cutting-edge technologies like the James Webb Space Telescope. As researchers continue to investigate JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began rolling in from the JWST, cosmologists eagerly awaited the results. Many had been preparing their data analysis pipelines for this moment for years. Instead of following the traditional peer review process, which typically takes months, experts chose to share their discoveries on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed a new form of peer review to occur through online platforms like Twitter, where established experts could quickly discuss findings. Rohan Natu described this process as science by press release, and the resulting storm of discussion was both intense and exciting. However, there were concerns about the potential downsides of this rapid dissemination of results. Klaus Pontoppidan, a JWST project scientist at STSCI, warned that while the quick sharing of results facilitated rapid dissemination and discussion, there was also the risk of overwhelming the process. The general understanding among most experts is that the hypothesis of how things came to be remains the primary explanation for the early times of the universe. This hypothesis encompasses the development of stars, planets, and life on those planets, including ourselves. Notwithstanding its odd name, the huge explosion offers a convincing explanation for what might have happened at the universe's origins. The universe was densely packed into a space smaller than a pinhead, filled with tightly packed particles. From this moment, a massive explosion of matter and energy occurred, known as the Huge Explosion. This event, happening billions of years ago, set the unfolding of cosmic history. However, changes in scientific understanding have led to developing anomalies with the assumptions of this hypothesis. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, investigators estimated that its observations would support the hypothesis of the universe's origin. Unfortunately, after just 1 year in space, the telescope astonished experts with its ability to peer deeply into the universe's past. The James Webb Space Telescope's astounding capabilities have uncovered galaxies dating back to such ancient times that they challenge our understanding of the universe's beginnings. This discovery has sparked a serious assessment of what could have existed before the enormous detonation. This revelation has not only challenged existing cosmological theories, but has also opened the door to entirely new questions about the universe's origins and its earliest structures. For decades, the enormous detonation has been the cornerstone of our understanding, but the James Webb Space Telescope's findings suggest that the early universe may have been more dynamic and complex than previously believed. The discovery of ancient galaxies, some appearing far more developed than expected, raises fundamental questions about the processes that govern their formation and evolution. Scientists now face the challenge of reconciling these observations with established theories. Did the universe evolve faster than our current models predict? Are there unknown mechanisms at play that accelerated the formation of stars and galaxies? These questions are driving a new era of scientific inquiry, as cosmologists and astrophysicists analyze the data provided by the James Webb Telescope. The telescope's ability to observe infrared light has proven to be its most significant advantage. As light travels across the expanding universe, its wavelength stretches, shifting from visible light to infrared. This phenomenon, known as redshift, allows the James Webb Space Telescope to see light from galaxies that formed shortly after the enormous detonation. These ancient galaxies provide a glimpse into the cosmic dawn, the period when the first stars ignited and galaxies began to take shape. By studying these early systems, scientists hope to understand how the first stars formed, how galaxies assembled, and how the universe transitioned from a dark, dense state to the vast, complex cosmos we observe today. The James Webb Telescope's observations have already revealed galaxies with unexpectedly high masses, brightness, and structure, challenging the notion that early galaxies were simple and chaotic.